Yeah, hello, my name is Christoph Berndt. So I think the introduction has been done. Just a short overview what I want to talk about. I just want to give a short overview what Zerone is and what we does. And I want to explain two projects that we did based on the Unreal game engine. Okay, Zerone started 1997 as a typical retouching company, so we worked with photographers and did simply retouching mainly for the automotive industry. And in 2005, we founded a 3D department to add the CGI workflow into the print advertisement. We have 34 employees. We have offices in Hamburg, in Düsseldorf, in Berlin, and we will open an office in Pforzheim very soon. And one thing that is not typical for a retouching company is that we have a research and development department, which is the company OX1. And we founded OX1 to develop a pipeline to improve the workflow for CGI production in print advertisement. And when we figured out that the tools that we built are really useful also for others, we made some software products out of it. So we started with the software development. And we had two products that we offer for the public, which is Iray for Maya. Iray is a GPU-based renderer from NVIDIA, and we implemented it into Maya. And this is a product that you can buy. And we invented FPO, which is the software that I will introduce right now. And the fact that we have a development department and that we worked on different technologies made the bridge to some VR and also some AR projects that we are currently working on. So this is the stuff that we usually do. So all these images have one thing in common. So the cars are all rendered, so these are all CGI cars, and all the photographs or the images in the background. These are all photographs done by various photographers. And we also do full CGI project as well, or we do the other way around. So we have a photographed car, and we have to create a CGI environment. But the story that I want to talk about is this typical problem of a CGI automotive photo shooting. And the typical problem is that the photographer is on a location, and he has no car available. So he's somewhere in the mountains or wherever, and there's no car. So then he has a problem. He has to do the photo, the image, and he has to imagine how the car should be in there. Or the other problem that is that you maybe have the car for the shooting available, but you're not allowed to place it in this location. You have a nice location, but it's simply not allowed. Or the other thing is, when you want to place the car in this image, there's no 3D expert around, because the thing is that you have a model of the car, and you need some software to place the car. And in this situation, you also, you are lost. You can make the photo, but you have no chance to counter-check if the car will fit into this location or not. Because we have lots of photographers and agencies dealing with this problem, we developed this software FPO, which is the solution to this problem. So FPO is really easy to use. It's a free software, so it's currently a little bit in beta. But we have photographers like this photographer here, Michael Hegele, who's using it for a portfolio for his own work. Or we have companies like Marground using it. So Marground is a stock agency delivering images and HDR images. Maybe you know this. So they're using internally the software to place cars or work for customers. And all these guys are no 3D experts. Okay, and I want to show you how FPO is working, because I think that's basically this is FPO. So you have some user interfaces that you can move around here, and you have in the middle is this dummy object. So you can rotate this object, And there's a company in Germany, Dodge Design. They sell 3D models of cars, HDR images, stock images, and stuff like that. And they delivered a set of free models that can be used. So even if you don't have a specific model, you can use this tool. You can use this model. So now it's loaded. And now you can place this model in any location. And so this tool is built for photographers. So you have a camera here where you can deal with. You have this objects level here where you can import objects, and you have a lighting situation. And the initial idea is that you can shoot every picture, or you have a stock of images, and you can create these. You can load these images here. So I simply go to this project, load this image, which is done from the camera, and load it on this tablet. And the next thing is that for specific projects, you maybe need specific car models. And we have the chance to import CAD data, or we can model our own stuff. In this case, it's a model bought from TurboSquid by the photographer. So now we can place this car in this location, and you have to think as a photographer. So the first thing that you have to think about is which kind of camera did I use to make the background image. So it's a regular camera here, like a Canon or so. You can adjust the focal length here, and then you can define the height of the camera. And you maybe know that you're a little bit lower with the camera, and you can define the distance. And now you can place the car here and rotate it with the handles. Or you can also use these sliders here. And basically, the car is more or less positioned. So I can fine-tune this. That is not a real big issue. It's just a little time-consuming. Or not time-consuming, but it will take some time. And when you place the car, you can go to this sphere here, and you load an HDR image which is corresponding to the background image. And now you can do the rotation, or you can rotate the light around this object. You can modify the exposure, and you can soften or harden the shadow, make it darker or lighter as you like it. And the car is more or less placed, done. And this is easy to use. I mean, as I show it to you, I'm quite sure I can give the pen to everybody else in this room here, and you can use the software. The software. This is the initial idea. So the idea is to have a tool that helps us to do our jobs, which is photo shooting, taking the car, render it into the image, do the retouching. But for us, it's very helpful when the agency or the photographer can cross-check on location the situation, and they are not 3D experts. And that's the reason why we created the software that everybody can really use it. So it's really simple to use, and that's it. That's the whole story. And the thing is that this technology is based on Unreal Engine. So we took the Unreal game engine and modified it that the software will do this kind of job. And this, the reason is that we have a platform that runs on a Mac and on a PC, like this Wacom tablet that I'm using here. So you don't need a fancy hardware workstation or something like that. It's a simple tablet, MacBook, whatever, that can run the software. And the other thing is we are able to load custom projects, custom models. So this tool is intended to be used in car photography and on car shootings. But you can load any other object into it. We can load a monitor or washing machine or whatever you want, and you can do this kind of layout work based on FPO. And for us, a very important aspect is that all the knowledge that we get when we created the software can be used to work on VR projects. So because it's Unreal, we can simply modify it, and we can do some productions that are far away from our initial thing that we are doing, which is retouching and rendering objects into images or doing print images for advertisement. With this technology, we can take this experience from this photographic world and transfer it into the interactive world. That's the intent why we used the Unreal game engine. And that's the reason why I want to talk about this, the next project, which is for a German company, which is named with the name GOM. GOM is a German company producing optical scanners. And these optical scanners are used in the automotive industry or in the aeroplane industry to measure objects and compare these with the CAD data and to see how precise it is and all that stuff. So it's engineering stuff. I'm not an expert in this, but this company is they really create high-end and very precise objects. And they introduced a new product, which is the GOM CT, which is an industrial computer tomograph. And with this object, they are able to inspect volumetric objects. And the measurement is based on an X-ray source. And that's the problem. So when they have this CT with this, which is really huge, it's 2 meters high and 2 meters deep and 4 meters wide or whatever. So it's really huge and it's heavy because everything is in lead because it's an X-ray source. And when you want to place this on a trade show like here, you have to deal with the government because it's X-ray and you have a lot of security things to have in mind, and that's really complicated. And the problem is that everything that happens, what makes this object interesting, happens behind closed doors. So when the CT is operating, it closes its doors, and now you're lost. You cannot explain to the customer what the features are. And we said to the customer, or together with the customer, or with the agency, working with the customer, and we showed them this FPO tool. And they say, oh, yeah, that's quite cool, it looks nice, and it's easy to use, or easy to operate. Probably we can create some kind of a demonstrator that explains this technology. And we said, okay, yeah, that can be done, it's not that complicated. And then we simply started the idea to build a CT demonstrator, which has more or less the dimensions of the original object, but it's lighter and smaller because it does not have all this technology inside. It's just the outer body, and it's lighter because it's high and it's wide, but the depth is not like the original thing. So it's easy to transport and to set on a trade show. And it's easy to use because we can control this software with this controller here. And we did an animation, a technical animation for a movie to explain this CT. And in this film that we did, we had real shooting of the CT. But for the explanation of the technology, we used this animation, this typical computer graphic animation. And for this animation, there was a look defined, which is like the object that's been explained will get the material, and all other objects has this white look around, this ambient occlusion look. That was a wanted thing from the agency. And we have to and our target was to transfer the same look into this demonstrator, into this app. And yeah, that's the way it goes, and that's the way how we created this demonstrator. We'll just have to take a look at the time. And I think it's time, or we can take the time. And I can show you the demonstrator, which is simply based on the same technology as FPO. So for this, I will connect the controller. So it's a game controller that I stole from my son today, from the PS4. So that's it. So this is the app. It looks more or less the same as it looks for the, for the movie that we did. And the good thing is that we now can, or that the engineer can now explain how this machine is working without explaining a movie. He can control it, so he can just take the controller and move the camera around. So we have the help here because I'm not the engineer. I cannot explain you the CT, but I can explain you why we did certain things. So what we can do, we can show the labels because there are specific features in this machine, like the X-ray source or the temperature balancing. So you can enable these things. Then you see this red sphere. This is the probe, which is measured. This can be changed. You can operate this for kinematics, which is a very important feature. So that was really important for them, that you can handle this, that you can move it around, or that you can rotate it. There's also a demo mode, so I can press the button and then the animation will start. And so this is like the movie that we did. It's more or less the movie. And you see that the material is changing. But when the customer's on the trade show and he says, "Yeah, I want to know something about this turntable there," then you can stop this. You can go to different camera positions and operate this and explain the thing here. So one thing, for example, is that that this probe, when it's X-rayed, it must be centered so that it fits to the sensor. And there's also this feature, for example, in this machine, that you can automatically position the probe, which is like that. So now it drives automatically in the position that it perfectly fits to the sensor. So, and this is simply what we did based on the Unreal Engine. And that is simply the same technology as FPO. We showed it to the customer, and he said, "Okay, great technology. Can we have we want to make another project out of it. Can this be done?" And that's the story of this of this project. So the thing is, initially we are a retouching company. During the time we added the CGI technology to our productions. And now we are in the situation where we use game engines and VR projects to extend our business. So customers coming to us just to have a nice picture will get an interactive, or at the end we'll get an interactive product that they can use for trade shows or for whatever. And so we're able to create custom software to fit these needs. And we're trying to be the gap, trying to close the gap between this creativity that our company stands for and the computer graphic world that is complicated, and for some customers it's far away. And we can connect these worlds together. So we have the knowledge how to create nice images, and now we are getting more and more projects and the knowledge how to transfer this into in the interactivity and into interactive projects. Okay, I hope you got the idea. And if you have any other questions.